Fine. Ready? Okay. Basically, this topic is like a continuation of what you did last semester in the first project. Remember the first project from last semester? Yes. In that project, what you did was using derivatives to find how to solve free-fall problems or motion problems. This case here in Math 6, we're going to do the inverse process. We're going to use integrals to get what? The acceleration, the position, and the velocity. Okay? So if you remember that project, this one is going to be basically the same. Very easy, just integration. If you don't remember, well, too bad, but we'll see how to do it still. Okay. So one of the applications for integrals is this, which is the solution of motion problems. When I say motion problems, I mean vertical motion problems or horizontal motion problems. Could be both. But remember, in Math 5 and here in Math 6, when I want to use the function to represent the position, velocity and acceleration, we don't use f of x. We're going to use s of t. In this case, s represents the position, and t, the variable, is going to be time. Okay, the time. So the variable here is time. And this one will be the position. So the first one, s of t, is going to be the position function. And it represents basically the position of an object at any moment of the movement. Okay? The derivative of that is going to be what?
Velocity.
The velocity function. And the second derivative, or derivative of this one, is what?
Acceleration.
Acceleration. Function. Okay? And remember, in this case, for example, if we have this and we go to this, the process is the differentiation. That is derivative. By the way, in case you don't remember, the process of finding a derivative is called differentiation, not derivation. In English, we don't say derivation, it's called differentiation. And the inverse process, if we have acceleration, is the integration process. Or anti-differentiation. Okay? We're going to do an example with everything. All kinds of questions that could be in the exam. Okay. That one. The question says, a rock is thrown upward with an initial velocity of 50 feet per second from the top of a building that is 100 feet high. Find, question A, s of t, the distance from the ball to the ground, and time t. You have that problem. Do you know what it means? Do you understand what it means? It's basically a rock is going to be thrown upwards and it's going to fall downwards, right? Initial velocity of 50 feet per second, initial height of 100 feet. So first, what's my data? What do I have in this problem? Initial velocity. Initial velocity, we're going to call it v sub 0, is going to be 50 feet per second. Mathematically speaking, what does this represent in terms of the functions that I have? What do they represent? What does this represent? Huh? But how do I put it then? S prime of 0. S prime of 0. Why? S of prime t is the velocity function, but this is a value particular. It represents the velocity when the time is 0. That is when the movement is going to start, right? And the next one, 100 feet, what's that?
Initial position.
Initial position, so S sub 0, 100 feet. Mathematically speaking, what is that? If this one is S prime of 0, the position is going to be S of 0, okay? Velocity when the time is 0, position when the time is 0. So those two are what? Those two are my initial conditions, yeah. Like the ones that we saw yesterday and Friday, remember? Very good. Now, can I start my problem now? Can I find the position function? I'm missing something. I'm missing the function that I'm going to integrate, right? So, which one is it? Okay, deceleration, yeah. I have initial condition for this, initial condition for this. I need this. Do I have it? Yes. It's implicit. It's a free-fall problem. Like the ones I showed in physics. When it's free-fall problem, the acceleration function is gravity. Gravity. So in this case, S double prime of t, the function, is equal to what? What's the gravity? In feet per second squared, it's going to be minus 32. Yeah. So minus 32 feet over second squared. That's the function that I'm going to integrate. Do you understand why? No? Why? Okay. Remember, this problem is a free-fall problem. So in free-fall problems, such as this one, the acceleration function is always the gravity. Yeah? And it depends. If the units are in meters per second, it's minus 9.8 meters over second squared. If it's in feet, like in this one, then minus 32 feet over second squared. Okay? So this problem is in feet, so we're going to use minus 32. Okay? If the problem is not a free-fall problem, I need to specify the function. Okay, I will specify the function. It depends, it could be something different. Very good. Now what?
We integrate.
We do what we did yesterday. So integral of minus 32 what? dt. Why dt and not ds? Because the variable is time. Okay, so be careful because if you put ds in the exam, wrong. Be careful. And what is that? That is going to be s prime of t. The integral of that. So the solution is going to be minus 32 t plus c. Can you get the value of c? Yeah, from here. So s prime of 0 minus 32 times 0 plus c equal to 50. So c is equal to 50. And my velocity function is minus 32t plus 50. That's what? That's my velocity function. Do you agree? Questions so far? No. And if I want to get the other one, the position function, what do? Integrate again. S of t equal to integral of minus 32t plus 50 dt. Integrate that, so it's going to be minus 16t squared, very good, plus 50t plus c, and then the same again. S of 0 minus 16, 0 to the square, blah blah blah, 50 times 0 plus c equal to 100, so c is equal to 100. So the position function is minus 16 t squared plus 50t plus 100. And that's it. Position function. What is the position function? Represents the position at any instant during the movement, during the motion. Good. Questions so far? Okay. This is the mathematical part. Now the next question will be more like physics. I think you saw on last semester. For example, can I erase that part? What happens if the question says find or define the time it takes for the rock to reach maximum height? What do I do in that case? If the question is the time to reach the maximum height? Any ideas?
Gravity is zero.
No, gravity cannot be zero.
La velocidad.
Velocity is zero. Yeah, why?
Porque se mantiene maximum point.
Exactly. When you throw something up, there's like an instant when the velocity is going to be zero. It stops there and the gravity acts, so it's going down. So yeah, in that situation, the velocity, you can put it like that, you can put it like this, is equal to zero. So it's going to be minus 32t plus 50 equal to 0, and then what? Isolate the time. So 50 equal to 32t, t equal to, I think it was 1.56 seconds. Yeah. Pleasure. Find the maximum height. How do I find the maximum height? Exactly. Position function, which is s of 1.56, will be minus 16 1.56 to the square plus 50 1.56 plus 100. How much is that? Okay. That's the maximum. Questions? No?
Yo solo no entendía la parte que pides el tiempo.
Ajá.
O sea, la ecuación, la que está en negro, ¿dónde la sacaste?
That's like the requirement for this to follow. When you have the maximum height, you know it's like a condition that the velocity is going to be equal to 0. because you go up, down for a moment, and then goes down. So you use that condition to put the function equal to 0, ask for the time, and then solve it. And then with the time, you put it in the position function to find what? The maximum height, which is a position. Okay? Yeah? Careful. In this case, for example, observe what I'm doing here. What I did to this, I put s of 1.56. If you put s of t and then this is going to be incomplete because you're putting the value because you're going to substitute the value. So you're going to substitute this value, that's what I put. If you just put s of t, it's not correct entirely. Next question. Find the time to reach the ground. In that case, if I want to find the time that it takes for the rock to hit the ground, to reach the ground, what do I do? Yeah, the position is going to be 0. Okay? Remember, unlike in physics, in calculus, the 0 is always the ground, not the initial position. The ground is 0. So, the position equals to 0, so it's going to be minus 16t squared plus 50t plus 100 equal to 0. What do I do to solve it? How? Could you factor that?
Pero pues primero podríamos despejar el 100, ¿no? Para poder factorizar.
No, no puedes. That's better. Okay. General formula always works. So if you want the general formula, better. If you can simplify, you could by factorizing. It's up to you. But in this particular case, factorizing is not good. So general formula is always, well, it's more reliable. T12 equal to minus 50 plus minus 50 to the square minus 4, that's minus 16 times 100 over 2 minus 60. Do you remember how the formula works, right? Huh? Yeah, this is A, this is B, this is C. So it's minus B plus minus B squared minus 4AC over 2A. And we have two solutions. This is quadratic. Help me with that, this, the number's a little complicated. Minus what?
1.38.
Sure.
4.51.
51? Second. Okay. We have two answers. Which one is the valid answer? The positive one. Why? Of course, yeah. But could there be a possibility when you have two positive answers? Yeah, perhaps. So you need to choose the one that is most logical. In this situation, try to understand what they represent. What do those values represent? The time that it takes the ground. But why negative? Is that possible? No, but there's a reason why. Imagine the situation. is that there is a building, the ground here, here's the person, blah, blah, blah. So in this case, throws the rock up, and then goes down, right? It's 4.51 because you go up and then go down, it takes 4.51. But why minus 1.38? Because the problem or the mathematical calculation is assuming that it could also go in this direction. Of course, that's not possible because you go up and then you go down. Yeah, but remember that here is not actually just physics, it's also calculus in physics. So the mathematical explanation is because of that. But yeah, there's no negative time, you cancel that. But I'm explaining this because if, for example, you get two positive answers, you need to understand the situation of the problem and choose the one that is most logical. Okay? Because this theoretically could happen, but it doesn't. Okay? Fine. Next question. Find the final velocity. When it hits the ground. What do I do?
Position,
Where do they have that? The time where? In velocity, yeah. Well, we have the time that it takes to hit the ground. Now we find the velocity. S prime of 4.51 equal to minus 32. 4.51 plus 50. How much is that?
minus 98.32.
Minus 98 and what?
94.
94?
Yes. 0.32.
32 what?
Meters over second.
Feet over second. Careful with the units, huh? Feet over second. Okay, that's the velocity that when it hits the ground. Not zero, that, because it's an instant before it hits the ground. Question for you. Why is it negative?
Because it's going down.
That's in physics. That's in physics. Because in physics, velocity is a vector. But in calculus, there's another explanation. Okay. Remember the last topic that we saw last semester, which is... Huh? Yeah. And it's correct, yeah. As a vector. But in calculus, another explanation. When you saw, or when we saw last semester, rate of change, what happened, or what was the meaning of a rate of change that was negative? Exactly. So in this case, for example, if you remember from last semester, we found that f prime of x means dx over dy, right? In this situation, s prime of t represents ds over dt, right? S is the position. So what this means is that the distance to the ground is decreasing. So the rate is negative because it's decreasing. That's why if I were to take the velocity here, it will be positive because it's increasing the velocity, increasing the distance. Okay, be careful with that. But you're right. It's because it's going down, it's a vector and everything. But here in calculus, it's a little different. It's because this is a rate of change. And the distance to the ground is decreasing. That's what it means. Do you understand that? Sí. Poco a poco, jóvenes, voy a hacer así como que conexiones con Mate 5, que nomás se las olvidó ya. Es posible, a lo mejor no este quiz, pero en exámenes y eso, vamos a meterles preguntas así como de que le piensen un poquito. ¿Sí? Luego las motive, pero también hay que meterles, ¿para qué? Para que también lo vean. Porque en el examen final, en el examen AP, el que tomen ustedes dos, el que sea de los dos, pues les vamos a preguntar así cosas medio capciosonas. No de teoría, sino que lo sepan para que lo usen en una pregunta de responder con números. Para que no digan, es que lo vi pero se me olvidó. No. Yo a los meses los expliqué esto. ¿Se acuerdan que se los expliqué, verdad? A los que les di clase, pues.
Sí.
Y también Tibe se los explicó seguramente. Entonces, por eso hay que hacer las conexiones con eso. Muy bien. Last question. Find
One, that's mine.
a lot.
Oh my god.
Now, I'm not going to ask everything in the quiz, of course. I'm just covering all possible questions that could be in the 10. Yeah. Position and velocity after, let's say, 3 seconds. This is easier. What do I do?
Look in the curve.
Just substitute. Just substitute. The position is of 3 minus 16, 3 to the square plus 50 times 3 plus 100, and the other one s prime of 3 equal to minus 32 times 3 plus 50. How much is that? 100 what?
202.
200.
Square.
200 is more than that. That's impossible. 106. That's it?
Ah, yeah.
Fit. And the other one,
Minus 46.
minus 46
Sí.
feet
Over.
per second. Very good.
Mr.
Yeah.
Can you explain again what's the difference between the minus here and the minus here?
In physics, you saw two quantities, scalar and vectors, right? Vectors were about direction and the magnitude. But here in calculus, remember that we're taking the ground as the base level, as the zero. So it doesn't matter that it's going up or down. That's only got to do only when you have increasing or decreasing of the position or the velocity. For example, S prime of t, velocity, represents change in position over change in time. When something is falling, what happens when my position or my distance to the ground is decreasing? So if this is decreasing, the rate is going to be negative. When it's increasing, because if you go up, the distance is increasing, then the rate is positive. What about gravity? Gravity is acceleration, right? Gravity is always negative. Yeah, but gravity, acceleration, which is the change of velocity over time. It means that, for example, if the gravity is always negative, it means the velocity is always decreasing. When you go up, the velocity is decreasing because the gravity is acting. When you go down, it's increasing but negative, more and more and more and more negative. So they have to do to each other. Okay? So they have to, they're not independent or exclusive to each other, but they have to do to one another. Okay? Do you understand that? Yeah, very good. Es muy fácil de entender, o sea, el semestre pasado cuando vimos problemas con los de la sombra, ¿qué hacemos con el problema de la sombra? ¿Qué hace con la sombra? Ah, pues la sombra está haciendo cada vez más chiquita. Tenemos que poner que me daba negativo, que está haciendo cada vez más chiquita la sombra. O sea, la velocidad era negativa. Misma aplicación. Es lo mismo. Es nomás que da la diferencia entre física y cálculo en cuanto a la aplicación. La única diferencia. Okay. Questions? No? Sure? Good. They can repeat it.
¿Va a ser una de la actividad?
Y cuatro.
¿Cuál es la fase?
Today, try it on your own, and tomorrow at the beginning I'll do one. Okay, this activity is also very short, just 8 problems. It's going to be due Friday, because Friday is a quiz. So you need to study for the quiz. But I'll give you tomorrow to work on the activity also, so you have more time to do it. Okay, so work on the activity. Tomorrow I'll do one, but right now at least try to start. Okay? You can ask me questions if you want. No, there's no more.
Yo creo que ya termina de grabar, ¿no? Que si la actividad, sí, yo creo que ya termina de grabar.